Think math.
A half plus a quarter plus an eighth. Keep taking half and keep adding forever. Adding forever sounds like the total should grow forever, but it settles at exactly 1. How can an endless sum land on a clean number? Draw a square of area 1. Shade half of it. That is the first piece. Shade half of what is left, and that piece is a quarter. Then an eighth, then a 16th. No matter how long you keep going, the shading never leaves the square. The empty part just keeps halving. Now check it with numbers. 1 piece gives a half. 2 pieces give 3 quarters. 3 gives 7 eighths. 4 give 15 sixteenths. Do you see the pattern? Each total is 1 minus the gap that is left. And that gap is a half raised to the power n. So as n grows, the gap runs down to 0. The formula says the same thing. Last time we had the sum of the first n terms, the first term times 1 minus the ratio to the power n, all divided by 1 minus the ratio. When the ratio has size smaller than 1, the ratio to the power n runs down to 0. So the top just leaves the number 1 behind. The endless total is the first term divided by 1 minus the ratio. Here the first term is a half and the bottom is a half, so the answer is exactly 1. There is a condition, though. This only happens when the ratio has size smaller than 1. Take a ratio of 2, and you get 1 plus 2 plus 4 plus 8, growing without end. Take a ratio of 1, and you add the same number over and over, so it also runs away. Take a ratio of -1, and the totals bounce between 1 and 0, never settling. Only a ratio smaller than 1 in size brings the sum to rest. To sum up, adding forever does not force the total to be infinite. If the pieces shrink fast enough, the total comes to rest. For a geometric sequence, the test is whether the ratio has size smaller than 1. When it does, the endless total is the first term divided by 1 minus the ratio. Shade a square by halves forever, and you still never leave the square. A sip of math. Every day here at Think Math.